Hi, welcome to Tech Foundation. I am Eric Obin, aka Professor. This is the first episode of the Electronics 101 series. Now, in this episode, we will talk about what electronics is and how it differs from electrical. We will also look at the origin of electricity and try to understand some basic terminologies. Initially, I planned to make the video shorter, but I think it will rather be a good idea to allow the video have a natural breakpoint since it's going to be a weekly release. So I want to be able to tackle and complete a concept each week. So pardon me if we get a lengthy video, it's for your own good. Alright, let's get started. Most often, people get confused and interchangeably use the terms electronics and electrical. However, there is a subtle difference between electrical and electronic system. Electronics deals with the emission, flow, and control of electrons in vacuum and matter. The field of electronics comprises of physics, engineering, technology, and applications. Now, electrical, on the other hand, usually deals with transmission, distribution, and usage of electricity, with little or no concern about the manipulation of the motion of the electrons. For a system to be electronics rather than electrical, it has to contain at least one active component like a diode, transistor, etc. Electronics focuses on manipulating the electrons in a simple or complex manner. The path traced by an electron is called a circuit. The basic model of a circuit mainly consists of a source and a load. That is, the source releases energy to drive the load. Now, depending on the load requirement and the operation of the system, the circuit could involve variety of electrical components such as batteries, resistors, capacitors, transistors, diodes, etc. Electricity is the source of energy for electronic systems. This could come from batteries, solar panels, power supplies, and the likes. So, what is electricity? Electricity is a form of energy, as most of us know, which results from charged particles such as electrons, protons, ions, and later we'll get to know about something called holes. Charge is a property of matter that makes it experience a force in an electromagnetic field. Now, we shall talk more about this in later episodes. There are many forms of energy. We know of sound, nuclear, solar, mechanical, wind, geothermal, etc. But why is electricity preferred to these other forms of energy? If you take a typical home, some people generate electricity using diesel, LP gas, solar, wind turbines, hydros, etc. You realize that we convert other forms of energy into electricity. Now, why do we do this? Electricity, as we know, has very interesting characteristics that makes it an ideal choice for our daily energy source. First of all, it is versatile. That is, it can be transformed into other sources. For instance, with electric motor, we can transform electrical energy into mechanical energy. With a speaker, we can convert electrical energy into sound energy. With a heating element, we can convert electrical energy into heat energy, and so on and so forth. Secondly, it is transportable. We can transport electricity from their generation centers to very distant places, thousands of kilometers away over cables. The world, for instance, is linked together to share information, and this is because of the transportability of electricity. Thirdly, electricity is very fast. The motion of electrons is very fast, virtually closer to the speed of light. That is why it takes a few seconds to transmit electricity across a country when the switch is activated. Furthermore, It can be stored usually in batteries. It makes it possible to take some energy reserves along when we travel or go into very remote areas where there is a chance of not getting access to electricity. It is very easy to acquire portable power banks to store enough energy to recharge our mobile devices like phones and tablets. Also, electricity is very silent. We can barely hear any noise in our transmission cables. Imagine if sound energy was running through these cables. So, the next question that comes to mind is, where does this amazing source of energy originate from? Previously, we said that electricity is as a result of charged particles. So, where do these charges come from? Matter, as we know, is made up of atoms. Atoms are the building blocks of matter. Elements, molecules, compounds, and the universe are full of atoms. However, atoms are not the fundamental particles of matter. Atoms themselves are made up of three fundamental particles called electrons, protons, and neutrons. So if we take an atom, we can have the central nucleus and the electrons. Now, inside the nucleus, we will find two other particles, which are the protons and the neutrons. The protons and neutrons collectively are called nucleons. The atom has a central nucleus, which also happens to be the massive part of it. The nucleus contains protons and neutrons. Electrons, however, orbit around the atoms in shells, that is according to Bohr's model. Every atom has a fixed number of protons. The number of protons in an atom is called its atomic number, and it is symbolized by the letter capital Z. Now, when atoms of the same kind are bounded together, they form an element. Elements are arranged in the periodic table according to their atomic numbers. So if we take hydrogen, for instance, which is the first in the periodic table, it has an atomic number of 1. Helium is second and it has an atomic number of 2, and so on. The number of protons in an atom cannot change, unlike the number of electrons, which can change, resulting in the formation of ions. That is to say that an atom cannot lose or gain in protons. The moment an atom loses or gains in protons, a different atom is formed. Protons are assigned a positive charge, whereas electrons are assigned a negative charge. Now, this is a convention we use for mathematical reasons. We could equally say up and down, east and west, or anything that makes it possible to identify them. So, in an atom, there are equal number of protons and electrons. Hence, the total negative effect of the electrons is cancelled by the total positive effect of the protons. Therefore, an atom is said to be electrically neutral, meaning an atom has no electric charge. Although both protons and electrons carry charges, it is only the electrons that contribute to electricity. Now, a proton never leaves the nucleus to contribute to electricity. When charges are confined in a region and are incapable of movement, we call them static charges. Electrostatics is the study of the forces between charges at rest. Now, according to Coulomb's law, like charges repel and unlike charges attract. The force between the charge is proportional to the product of the charges and inversely proportional to the square of the distance between them. And this is the statement of Coulomb's law. If you take a look at this diagram, we have two positive charges and you can see that the forces are moving away from each other. This denotes repulsion, but down here we have a positive charge and a negative charge, and this denotes attraction. So mathematically we can express Coulomb's law as K times q1 q2 all over r squared, where this r is the distance between the centers of the charges. q1 and q2 are the respective charges. Now k here is called the Coulomb constant, and its numerical value is 8.987 Newton meter squared per c squared. C here is the speed of light in the vacuum, and its value is 3.0 times 10 raised to the power 8 meters per second. Although static charges can build up to thousands of volts, they are less useful in generating the required energy for the appliances we use. For a substantial generation of electricity, we need charges in motion. Now, take copper for instance. It is the 29th element, hence it has 29 protons and 29 electrons. When the electrons are arranged in shells, one electron remains in the outermost shell. The outermost shell is also called the valence shell, and as such, the electron in the valence shell is known as the valence electron. The valence electron is shielded by the innermost electrons from the nuclear attraction, and this is called the screening effect. This screening effect greatly reduces the influence of the nuclear attraction on the valence electrons, making it almost unbounded to the parent atom. Hence, this electron is able to break away from its parent atom by just absorbing thermal energy from the environment. This is called thermal excitation. Now, when an electron breaks free from its parent, it renders the parent atom charged. The parent atom now becomes ionized, and the electron is said to be in the conduction energy level. Hence, it is called a conduction electron. When an electric field is applied, this conduction electron can move under the influence of the electric field and contribute to current. Now, how many electrons are we talking about? The mole is defined as the amount of substance that contains as many elementary entities as the rare atoms in 12 grams of carbon-12. Now, this number is also called the Avogadro's number, and it has a numerical value of 6.032 times 10 raised to the power 23 atoms. Now, if you take 1 mole of copper, it will contain 6.023 times 10 raised to the power 23 number of atoms, and each of these atoms contains a single conduction electron. So, if you take a piece of copper, you get a tremendous number of electrons. As the electrons move about, they are pulled and prodded by the surrounding charges in that space. Thus, the electrons keep latching onto different ion cores in the crystal, and you can see a demonstration here. You can see that the electrons keep hopping from one atom to the other, and that is what is actually happening in the element or the crystal. Now, a natural question to ask is, if the electrons are already moving, then why don't we measure current in any piece of copper wire when we connect a meter to it? Unfortunately, the movement of the electrons is haphazard. Hence, there is no net current flow since they do not move in the same direction. Now, let's take a piece of copper metal. Inside this copper metal, we will have an array of copper atoms, and this is what we call the crystal. Now, the blue circles represent copper atoms, and the red ones represent the ion cores as a result of those atoms losing their electrons to the entire crystal. Okay. Now, when we apply enough thermal energy, these electrons are able to break loose from their parents, and they begin to wander through the entire crystal. But then you realize that the motion is very haphazard, and there is no net direction or movement in a particular direction. Okay, so how can we get them to flow in the same direction? Now, this can be done by applying an external electric field. To achieve this, we can connect a battery or any power supply across the copper. This is going to generate positive charges at one side and negative charges at the other side of the copper. Now, when this happens, a field is established. Okay, and as soon as the field is established, it causes the electrons which were previously moving in a random fashion to now move in a specific direction. Now, it's not as if the electric field generates a highway on which the electrons move. No, the electrons still collide with the ion cores and even with themselves, but then because of the electric field, there is a net motion in a specific direction, and this is what contributes to current. Current is therefore the amount of electric charges that crosses a given cross-sectional area per unit time. Current is measured in ampere, which is abbreviated as amp or capital A. 1 ampere of current is defined as 1 coulomb per second. Now, as opposed to static electricity where electrons gather and remain at rest, current electricity deals with charges in motion. And whenever we talk about electricity, it is usually current electricity that we are referring to. When a charged particle moves, it creates a magnetic field. This knowledge will come in handy in later sections. Thank you for your time. That is all for this episode. There are some questions here I want you to answer. Now, if you are interested in answering, you can send your solution to techfoundationafrica@gmail.com and I'll review it and get back to you. Thank you for watching. Don't forget to like, share, and subscribe to our channel. I am Professor, and this is Tech Foundation.